First, we will be starting with the start points, and we will cover them in different operation types where the start points can be controlled. The first thing I'm going to talk about here is controlling start points in two-axis operations. Particularly, we'll start with two-axis and profiling. Profiling is probably one of the very commonly used operation types in two-axis machining operations. So start point is the location where your entry and exits are being applied. So as you program a profiling operation, when you go into the two-axis methods and pick profiling, this applies to all of our CAM products, whether you're running our standalone Visual CAD/CAM, or if you're running our plugins for Rhino, SolidWorks, or Libre, it applies to all of them. So when you go into profiling and look under cut parameters, by default, it is set to use the midpoint of the longest side in profiling. So what this means is when you pick a part region for profiling, the system will automatically identify the longest side, and it'll apply the start point. It'll determine the start point at the midpoint of the longest side. So in this particular example that you're looking at, you will notice that it determined this as the longest side because these two sides have some notches in here. So it figured out this is the longest edge. It does not have any like cutouts. So it applies the entry and exit. So since the start point is over here, the entry and exit is being applied at the start point. Now, we would want to know how can we control the start point. So you may not want the start point to be over where it is, the midpoint of the longest edge. So you may want to adjust that or control it to your needs. So you would want to go back into the profiling operation, and then in the cutting parameters tab, you'd want to clear this checkbox to use midpoint of the longest side. Now, when you clear this checkbox and generate the toolpath, you will notice that it automatically uses the start point of the geometry, the part region that you selected. Now, if you had selected a curve or a sketch, we use curves, the terminology curves in Visual CAD/CAM and Rhino CAM, and SolidWorks and Libre uses the terminology as sketch. So when you have curve selected, and if the curve is joined or merged, it's a closed curve, it uses the start point of the curve. So you can see that the start point is represented on the curve by a point. So if you're using Visual CAD, you can actually display the start point of the geometry. So we're going to display. You can click on display the region, curve region start point, and it'll display a start point for the curve. As you can see here, it displays the start point. So when you pick that curve as your machining region or the part region in the operation, it automatically uses that start point for the location where the entry and exits will be applied. So we will be covering entry and exits down the road. So the start point is automatically obtained from the geometry here. So now if you want to change the start point, so if this is a closed curve, you can change start point for a closed curve. The simplest way to do that would be to select the curve, or you can highlight the curve in the CAD, and then you go into the curve modeling tab. And once you're in the curve modeling tab, you will see in Visual CAD there's an option called change start. So the start point can be changed for any closed curve. And now you'll notice that I can move the start point along anywhere on the curve. So I can move it around. So for example, if I want to put it towards closer to the midpoint of this vertical side, I could even use some of these object snaps in here to bring it close to the midpoint, and then I left click on it. You will now notice that the start point of this underlying curve was changed. Since we changed the start point and the profiling operation was using the curve, you'll see that the operation is flagged dirty, and it tells you that the control geometry was changed, the start point was changed. So we need to update that. So right click, regenerate. Now the toolpath is updated based on the start point. Folks, you may have questions. How can I do the same in Rhino or in SolidWorks? And I'm going to cover that here in just a second. So Start points can be changed for closed curves by using change start. This is one of the ways to do it, to change the start point in the host CAD system. So in this case, it is Visual CAD. Now, if you're using Rhino, one of the ways to change it would be to basically select the curve in Rhino. And once you have the curve selected, you can actually display the curve start. There's a command called curve start in Rhino. It'll insert a point where the start point is. Or if you want to directly just change the start point, you can go to curve and then go down to curve edit tools. And there's this command called adjust closed curve seam. So when you select this adjust closed curve seam command, this will allow you to drag a start point. So you can see that it displays the start point and an arrow which shows the direction. So I can pick this and I can move the start point around in Rhino. So you can even use your object snaps to wherever you want to move it. So I'll move it to the midpoint of this side here. Left click, we change the start point, right click to accept the changes. So now you'll notice that I got to regenerate the toolpath to reflect the change and make sure that if I want to use the start point of the curve, not use the midpoint of the longest side. So we've now effectively changed the start point of the underlying curve in Visual CAD and in Rhino. We will talk about how to do this inside of SolidWorks as well. So one of the ways we would have to do it in SolidWorks is, since SolidWorks does not have the ability to move the start point around in the CAD system itself, we will have to use what is called predefined region. Now, if you go into SolidWorks, you pick your sketch geometry as your drive geometry for your toolpath and you generate your toolpath, you will notice that it uses the start point where the sketch began. However, you don't have a command similar to Rhino or Visual CAD to just drag the start point around in the CAD system itself. So for this, we've introduced what is called predefined regions or machining regions. So you can go into this regions tab under the machining objects browser. So if for any reason you're unable to view the regions tab, you can toggle it by selecting tools and machining objects. So you can go into the regions tab and you can define them as a curve region or a surface edge or flat area. So we've covered the regions in a different webinar, so you can go back and review it. But today we'll be just focusing on the start point, how we can effectively change the start point. So I'm going to first create a machining region from the sketch or the surface edge. I'm going to click on select curves, and with the selection manager open here, I'm going to right click and do either a select chain if it's a sketch, or you can do a right click select loop or select tangency. So now you have a sketch selected in here. So you will notice that it creates a predefined region, and you can see it highlights in green once the region is created. Now that you have a region defined, you can move the start point around using the tools that are built in Visual CAM. So you can click on select start point, and I'm going to pick the start point to be over here. Left click on it and then accept it. So in the CAM, in the machining region, we moved the start point of this geometry. So how can we apply this geometry to the toolpath? So you edit the profiling operation. Now, rather than selecting directly a surface edge or a sketch, you click what's called select predefined. Now, since this region has been predefined, we click on select curve region. And now let's go ahead and generate it. You'll notice that now the start point, it applies the start point of the region that you chose for entry and exit. This would be a similar process in also in AlibreCAM. So you define a predefined region and then you assign or pick a start point for it to do it. Now, if you want to do the same thing in RhinoCAM, you could do it. If you're working with just surface edges, you can use the regions tab to create predefined region by selecting surface edges, and you can pick a start point. The same feature is also available inside of Visual CAD CAM as well. You can create a predefined region and then pick a start point. So this is how you can control start point in profiling operation. Now the same also applies to some of the other operation types like chamfering and filleting operation, very similar to profiling. The start point applies in chamfering, filleting, and also in engraving, it uses the start point of the curve. Now, if you're working with an open curve, a curve that's not closed, for example, let's consider you have a polyline in here. So the start points is going to be on one of the ends. You can't move a start point for an open curve. You can only reverse the direction of the curve so the start point gets flipped over. However, the start point is basically going to be at one of the ends when it's an open curve geometry. The next thing I'm going to cover here is start points for pocketing operation. Now, before I get into that, looks like we have a question about start point with regions. So regions are basically creating machining regions. So you can click on select curve regions or surface edge region. So you pick a region. So the region is defined, and now you can use select start point, and you can move the start point around to wherever you like it to be. So I'm going to move the start point over here. So this is how you would create a region, a machining region, and then move the start point. Again, start point can only be moved or dragged around for a closed curve. If it's an open curve, like this one right here, the start point can be reversed or moved to the other end by selecting reverse direction, and it'll actually move the start point over here. Or if you want to do it in the underlying CAD system in Rhino and Visual CAD, there's a command called reverse curve direction. So if you go into the CAD here, I can select it and select the reverse command. So that'll reverse the direction of the curve, so the start point will get flipped over to the other side. In Rhino, you use the command called flip to reverse it. So this is how you can control the start point in operations like profiling, engraving, chamfer, and fillet machining operations. Now, the next thing I would like to cover is how we could control start points in a pocket operation. So I'm going to go into this example in here, and we currently have a pocketing toolpath programmed on this part. As you can see, it uses the high-speed cut pattern. Now, by default, the cutter will try to plunge and do the engage motion at the widest area in a pocket. The system is automatically designed to do that, so it identifies the widest area and it does your plunge and entry and exit motion. However, you may want to control the start point in a pocket operation. A good example, case would be you probably have like a pre-drilled hole on a part. So you may have a pre-drilled hole in here. So I created a drilling operation. I'm going to unsuppress this here. And so we have a drill operation created in here. And I've actually defined, I could do a drilling operation by just simply creating a point. So I have a point drawn in the CAD, and the point could be anywhere on the Z-axis. We've created a point, and then we perform the drilling operation in here. So that once you have a drill operation performed, so we have this drill operation, you would want a cutter to plunge in at the pre-drilled hole location for your pocket. So in the pocket operation, you now have the option to pick a start point. So when you go into the start point tab, you can actually select a start point, and you can just go pick the same point that you use for your pre-drilled hole. And then as you generate your toolpath, you will notice that the cutter plunges in and creates your ramp motion at the start point, and it creates this high-speed cut pattern from the start point to the widest area where it starts creating your spiral path. So in pocketing, this also applies in other operations like 2-axis roughing, 3-axis horizontal roughing. You can control the start point where you can have a pre-drilled hole, and then you can use the location of the hole, the pre-drilled hole, for your location where you want the cutter to enter in. Now, one thing I want to point out here is you want to make sure that the pre-drilled hole or the start point that you're picking is inside the boundary of the pocket and not outside. So I can't pick a start point over here, which is past the boundary of your pocket region, or I can't pick it on the edge. It has to be inside the pocket where the cutter can plunge and then create its entry motion in there. So this is also available in not only in 2-axis pocketing, you can do the same in 2-axis roughing. You'll also find this option under 3-axis horizontal roughing. And if you're running the Pro configuration, you'll also find it in the re-roughing operations as well. So the same also applies to other 2-axis methods like roughing, pocketing, as well as 3-axis roughing toolpath methods. So you can control the start point. So the start point can be controlled in these methods. Now let's take a look at facing. And in facing operation, you cannot pick a start point. The system gives you a choice to specify the start point location, cut start location. You can set it to at bottom. So when you set at bottom, and depending on the direction of your cut, so if the angle of cut or the direction of cut is 0, the toolpath traverses along X. And since in this case we've chosen the cut direction to be mixed, so it's going to, the start point when the angle of cut is 0 is going to be closer towards you or towards the bottom of the part, and it will work its way towards away from you. So that's what the start point at bottom refers to in facing operations. You will notice that the cutter will basically use this location. It could be this or this location for the start point. Now, if you wanted the start point to be over on the other side, you want to start at the top and work its way down towards the bottom, there's a couple of ways you could do it. One of the ways here is you can switch it from start at bottom to start to top. So you'll notice that now the entry occurs over here. Or you can leave it at start at bottom and then change the angle of cut. Instead of 0, you can use 180 and then pick generate. So that's how you can change the start location. Now if you change this to a 90 degrees, the cut pattern cut direction will be parallel to the y-axis, and you'll notice that the start point is over here on the right side. So you can control the start points when you're using the lace cut patterns or linear cut patterns in several operations, not just facing. In other operations too, you can control the start point. Folks, this gives you a brief summary overview of how to control start points in profiling, pocketing, and also we talked about facing operation. Please feel free to post your questions in the questions panel, and we'll try to get those questions answered for you.